Hello friends. So in last session we have seen the formula for a derivative of composite function. It is if y is equal to f of g of x, then dy by dx can be written as f dash of g of x into g dash of x. It is very simple formula, but till many students are getting difficulty. So before going to see solution of some example, so I will show you a trick in our usual language in our classroom. I used to say a word in Marathi, a kissa. So we'll see what is that kissa, how we can remember a technique of solving this derivative. So let us go for that. So already you are playing many mobile games. So here we'll use that technique here. So see what are the rules there. The task function is f of g of x. Now this is a fort, two layered fort, where f is the first gate which is locked and g is the second gate which is also locked, and x, she is the princess and you are the prince who is outside the this fort, and these are the two locks, and the name of the key is derivative. So let us go and play the game of unlocking it. Remember what is the name of key? It is derivative to unlock. Now we'll use the key. See, interesting thing, without opening the lock F, can we open G? No, it is not possible. So first you have to open the key F only. So see what we are doing. Now we are opening the key F, so it is open now, and because of this we have operated derivative delta dash on f only, and as we have discussed, there is no change in g and x. So g of x is as it is. Okay. So now the role of first gate is finished because it is already open. So f dash is finished, g of x is as it is, just we have written below there. Now we have to move to the next gate g. See how we can do that. Now the prince will move towards the gate g, that is the function g, and he has to use the key, that is derivative. So now he is operating the key on this g. So now it is going to open. Yes, it is opened. So we got this g key operated is dash derivative, so it is g dash, and x is as she is there, princess is inside that, and so we are getting first part f dash of g of x and second is g dash of x. And so now the prince goes to princess, they mate, and we know the further story. So this is what we got the method. So when we have two functions f of g of x, we have to operate the key dash, that is derivative, on the first function only, keeping the inside function as it is, and after that you have to leave the first door and then move to the second gate and again use the operator derivative, that is the key on g, so it will become g dash, it will open, and so you will meet the, just if we are remembering the example of y is equal to sine of tan x, we have done the same. Derivative of sine is cos, we have taken the derivative of sine only as cos tan x as it is, and in the second part we have taken derivative of tan x, and so it is derivative of dy by dx is cos of tan x into sec square x. This is the derivative of sine of tan x. So by another technique we'll see it, but before that, if we have three functions, how we can do? You have to do the same. It is f of g of h of x. So first operate on f, it will be f dash. You have to keep g of h of x as it is, then move to the next, multiply. So you have to operate on g, it will be g dash, h of x will be as it is. So g will can be removed now, and then go for h, operate on the derivative on it, it will be h dash of x. So by this method you can go. So if you got this, I think you got the clear idea, but till we'll see one more technique here. So you play different games on the mobile. So you have to play on level first. After finishing level first, you go for the level second. After finishing the level second, you will go for the x, and x is the final winning. So what we have to do? We have to play. See what are the games we are playing. We are if you are shooting there, or if you are shooting the ball there, or if you are cutting the fruits there, like that we have to, different games are there. Now here what you have to do? Here you have to do, you have to take the derivative. This is the operation. So this is a game like this. The first level, name of first level is f, name of the second level is g, and final destination is x. You have to reach up to x. So now we'll start our game. See, the name of this game is f of g of x. Now we'll move to the first level, and we have to operate by derivative. So we are operating the derivative in the first level, and what is the name of the first level? It is f. So after operating completely, see what it becomes. Now it will become, it will changes, and it will become f dash. So while we are doing all these things on the first level, there is no change in the second level as well as x. So they remain as they are, as we are till on the first level. So see what we are getting now. Now we are getting f dash, only change in the first level, no change in the second level and the x. So f dash of g of x. Now we'll move to the second level because we have finished the first level. So first level is finished. Now we'll move to the second level. We'll use the operator derivative. So we are playing the game at the second level now. So operate by derivative on the second level function g. So it will vanish and it will become g dash. But at the same time, see, there is no effect on x, x is as it is. So now we are getting, first part is as it is, f dash, there is no change inside f dash, that is g of x as it is. And now at the second level, our score is increased by g dash of x, because x is as it is. Now see what happens further. So we have removed it. Now we'll move to x, and if we'll try to go for the derivative of x, what is the derivative of x? It is 1. So if we go for the next level, it will remain the same. So it is the final answer. But some people makes the mistake. What they do? They write this f dash inside the bracket g dash of x. See, at one stage you are taking, you can take derivative to the one term only or one function only in case of composite function. So at the first stage you have to take derivative of outer function keeping inner function as it is, and then at the second stage you have to go for derivative of inner function. So we can't write this. So the step is wrong, f dash of g dash of x. I think now it is very clear to you.
Have you enjoyed the game of finding the derivative? So see, as we can play any game on mobile or computer if we are knowing the rule of the game. So like that only, if you are knowing the rules of mathematics, then mathematics is easy, or rules of derivative, then derivative is also easy. So just see the rules, what we have seen. Whenever we are differentiating a composite function, Always differentiate outer function keeping inner function as it is, and then go for derivative of inner function. Don't go for derivative of both functions at a time. So let's now we'll move to examples, and we'll enjoy solving the examples like playing the game.
So now let us start with the example. Find dy by dx if y is equal to under root x square plus 4x minus 7. So once again we'll write the given equation in the solution. We'll consider the given equation. Y is equal to, it is a root of x square plus 4x minus 7, and I will call this as equation number first. Just we can observe that this function is composite function, because first you have to operate on this equation x square, this relation, sorry, x square plus 4x minus 7, and then we have to take its square root. So it is a composite function. Now we'll call u to the inner function. What is that inner function? The bracket, it is x square plus 4x minus 7. I'll call this as number 2. Then the given function, composite function, will reduce to y is equal to a root of, now simply it is u. So now y is function of u and u is function of x. So this function is composite function. Now we have chain rule for derivative of composite function. What is that chain rule? dy by dx is equal to dy by du into du by dx. Call this is number 4. And our aim is to find this dy by du and du by dx. To find dy by du, see y is function of u, so we'll differentiate 3. Now I'll write here, differentiate this 3, equation 3, with respect to u. So we'll get it as dy by du is equal to 1 upon 2 root u. I will call this as next equation number 5, and also will differentiate to find the second term, du by dx here. This equation 2 with respect to x. So this is du by dx is equal to d by dx of, I will write u again, see u, this is x square plus 4x minus 7. And so by separating the terms, it is d by dx of x square plus 4 is constant, can be taken outside, d by dx of x minus d by dx of 7. Derivative of sum equal to sum of derivative, derivative of difference equal to difference of derivative, and here we have used one more property. When we have the product, then constant can be taken outside the derivative. So we'll write that here. Now derivative of x square is 2x plus 4 minus this is 0. So we are taking 2 common, it is x plus 2. This is du by dx. Now see, in the chain rule we got dy by du in equation 5 and du by dx in equation 6. So we'll use those. Using 5 and 6 in this equation 4, that is the chain rule, we get, see what we get, dy by dx is equal to dy by du is 1 upon 2 root u into du by dx is here, that is 2 into x plus 2. Now we can cancel 2 and we write the answer. But before that, see, u, we have used this variable. It is not given in the question. In the question, the function is in form of y and x. We have introduced u. Now we have to take out it. So we'll replace the value of u again. So we'll get dy by dx is equal to x plus 2. I will consider the product of 1 into this bracket divided by a root of u is x square plus 4x minus 7, and this is by equation 2, and so this is the final answer. I think now the solution is very clear here. Now we will solve the same example by another method. So I will consider the same function y is equal to under root, it is x square plus 4x minus 7. I will call this as first, which is in y is equal to f of g of x, that is composite form. We know that. So we have seen the formula for a derivative of it. It is a dy by dx is equal to derivative of outer function f dash keeping the inner function as it is, g of x, into, now we have to remove the outer function f and we have to go for derivative of inner function g dash of x. So I'll call this as second. Now here I will put the bracket here. This is the inner function. So see, what is the outer function? It is root, square root, and we know that square root of x, derivative of square root of x is 1 upon 2 root x. Now here instead of x we will say bracket. So square root of root of bracket is 1 upon 2 times a root of bracket. So it can be written as then dy by dx is equal to f dash function f is square root, so its derivative is 1 upon 2 root of bracket means this g of x into d by dx of g of x, it is the bracket. Notice that bracket inner function, it is x square plus 4x minus 7. I will write the same, it is x square plus 4x minus 7. So derivative of outer function 1 upon 2 root into inner function as it is into derivative of inner function. And now just go for derivative of this part. It is 1 upon 2 root of this part as it is, x square plus 4x minus 7 into, go for derivative of this part, x square is 2x plus derivative of 4, x is 4 and derivative of 7, it is constant, is 0. So taking 2 common outside and cancelling with this, we get the answer x plus 2 divided by root of x square plus 4x plus is minus 7, and this is the answer.
Yes, I hope you got the clear idea of this example. So we have discussed by both methods and we have gone for a similar example. Now you may solve the example by another method. So let's move to the next example.
Now using this alternative method, we'll go for one more example. Find dy by dx if y is equal to log of sec x. So we go for the solution. Consider the given function y is equal to log of sec x. So now see, this is the outer function log and sec x is the inner function, which is in composite form. That is y is equal to g of f of x. Then we'll write its derivative. Dy by dx is equal to derivative of outer function. It is a g dash into right inner function as it is inside it into derivative of inner function f dash of x. So I'll call this as 2. Purposefully I have changed g and f in the previous example and this example. It makes no difference. So you have to remember this. Now because of this, dy by dx is equal to g dash. What is g? It is log. And we know derivative of log x is 1 upon x. Now we'll say derivative of log of bracket. Derivative of log of bracket is 1 upon bracket into d by dx of bracket. Bracket is the inner function. And so now we'll write that inner function. It is sec x into sec x as it is here. And now just go for derivative of sec x. 1 upon sec x into derivative of sec x is sec x into tan x. And so we can cancel sec x here. And so we are getting simply derivative of this log of sec x is equal to tan x. And this is the formula. So students are requested to solve this example by the first method, that is calling sec x as u and considering y as log u.
I think now the interest is increasing. You are getting familiar with the concept of derivative composite function, how we can solve this. So here, friends, we'll go for one example which has some sort of complications there, and we'll get some difficulty in solving this example by first method. See what we have to do in this case.
So which is somewhat complicated compared to the previous example. Here there are inside the square root, again we have sum of two functions, so you have to use the derivative of algebra. But in that, the first function is simple x square and second is again a composite. So here it is mixing of all such functions. So this example can be solved by second method easily. So we may solve using first method, but we are getting some difficulty. Again, you have to consider different variables there. So it is better to solve by second method. So we'll see how we can solve it. Now I will consider the given function first. Y is equal to a root of x square plus a root of x square plus 1. I will call this is 1. And now I will put the bracket to the inner function, which is a composite function. That is, particularly we will write the form y is equal to f of g or g of f, whatever it may be, you have to fix it. So square root is f and this bracket now we will consider as g of x. Then we know the formula for derivative. Dy by dx is derivative of outer function, that is f dash, keeping inner function as it is inside it, into multiplying it by the derivative of inner function. So I'll call this as 2. So see how we can use here. Then dy by dx for first equation first. See, the outer function is square root, and we know that derivative of root x is 1 upon 2 root x. So like that, derivative of root of bracket will be 1 upon 2 root bracket into, you have to multiply by the derivative of bracket, that is inner function. Bracket contains the inner function. Now I will write that x square plus root of x square plus 1, and here it is x square plus root of x square plus 1. Now already we have finished the first part. Now we have to go for the derivative of second, derivative of x square plus root of x square plus 1, which is equal to, now here this, keep the first part as it is, 2 into root of this x square plus root of x square plus 1, no change here, into, now we have to differentiate this separately using the formula for derivative of sum equal to sum of derivatives we have studied in 11th standard. This is dy dx of x square plus dy dx of root of x square plus 1. If you are not remembering this, just go for the previous lecture on our channel. So here we have used d by dx of u plus du by dx plus dv by dx. So now it is equal to, no change in the first part, it is 2 root x square plus root of x square plus. So now we'll go for this derivative of x square is 2x, and again see, we have derivative for root of x square plus 1. This is composite. So once again we have used the same formula. So here a root of x square plus 1 is inner function and outer function is a root. So we have to go for 1 upon 2 root, I will write the bracket here, into d by dx of bracket. And what is inside the bracket? It is the inner function x square plus 1. Is it okay? So why you have done this? Because this is a composite function. Outer function is square root and inner function is a root of x square plus 1. So firstly we have gone for a derivative of outer function. So here derivative of x square is 2x plus, now here it is composite, outer function is a root and inner function is x square plus 1. So derivative of outer function 1 upon 2 root, derivative of root of bracket is 1 upon 2 root of bracket into derivative of bracket by the same formula, by 2. Just will go for derivative of this part only. So this is 1 upon 2 inside the square root x square plus root of x square plus 1 into 2x plus 1 upon 2 into root of x square plus 1, and now inside this bracket derivative of x, again go for derivative of sum equal to sum of derivatives here. So I will go directly here. Derivative of x square is 2x, or if you have doubt, just I will write that derivative of x square. It is not necessary, you can avoid this step and go for next step directly, which is equal to 1 upon the first part as it is 2 under root x square plus root of x square plus 1, the first part as it is, into, now we are simplifying the second part inside this bracket, no change in the first term, plus 2x upon plus it is 2 root x square plus 1, just we are simplifying this curly bracket only. So derivative of x square is 2x and plus derivative of 1 is 0, and now we have the product here. So this 2 gets cancelled with this 2, and so we are getting this is 1 upon 2 root inside the square root x square plus a root of x square plus 1, this is the first part, into, here it is 2x plus a root of x square plus 1, which is 1 upon a root of x square plus 1 into this x, so we may write this as x here. Now just you may keep as it is, or you can simplify this. This is the answer. Or
So friends, I hope you must have enjoyed solving the derivative of composite function. See, you have to learn the trick behind solving any example, not only the solution, but you must know how to solve it. So the knowing trick, what it gives, you can solve now any example by that method. So with this, we'll close today's session. As you have enjoyed it, if you like this video, click on it. If till you have not subscribed my channel, subscribe it and put on bell icon, because whenever I will give the next video on more examples on derivative of composite function, you will definitely give the notification. So thank you friends, we'll stop here only. Thank you.